Good morning, good afternoon, good evening, and welcome to the SHRM Talent 2020 conference. My name is Stuart Nisbet, Chief Data Scientist at Cadient Talent, and I'm very pleased to be able to present to you today. I am sad that I'm not able to do this in person and meet each one of you, but I wanted to talk about what we're doing in the area of prescriptive analytics and the future of hourly hiring. And this is the application, the true application of artificial intelligence and machine learning. And we have taken a very unique approach to this based on the data that we've collected through the years. So I want to start by trying to demystify exactly what machine learning and artificial intelligence are. And I've chosen a very simple example for how to do that, and it's the game of Tic Tac Toe. So let me demonstrate a machine learning system that we built just for this presentation. And hopefully it'll be a fun introduction into what machine learning is, and everyone can clearly understand exactly how a computer or a machine can learn. So we'll start with a very simple tic-tac-toe board here. The computer knows nothing about this game. The only thing it knows is that it's a 3x3 board, doesn't know the objective. It knows that when the human puts an X somewhere, it can put an O in any other location that's not previously taken. And it gets told when it wins, loses, or draws. And that's all that it knows. So in this very first one, it's just completely random. Wherever X goes, O just throws an O. The computer just says, pick a random spot that's not taken. So you can beat this one again and again and again. It's just randomly placing. Occasionally it'll throw one in the right spot, right? But then you can just kind of go down another way. So you can beat it over and over and over, almost any number of ways. But if we make just a slight change to the program, and don't worry, there's not going to be a test on Python after this, but you can win friends and influence people if you tell them that you're a Python programmer now. So all we'll do is, instead of just returning a random square, we've got a little bit of code here that helps remember how I lost before. Again, it doesn't know what losing means. It doesn't know what winning means. It just has a binary. I won, I lost. I guess it's not binary, or I tied. So let's run that one and see how it goes. So again, the machine, on the very first time, it's very random. It throws an O in a random spot. It's never played this game before. Random spot, it loses. Now it has experience, it has data, it has knowledge, it has learned. It's learned one thing. I didn't do so well when he put X's in the top row. So we'll go again. That was not a random move. That was learned from the first game that it lost. And so I can go right down this side, and it says, hey, all I learned is that when he was putting X's up here, I didn't do so well. So I beat it this way. Okay, one more here. Okay, it's not going to lose that way. It's not going to lose that way either. Those are not random moves. Those are moves that are born from a 3-year-old child who's played this game 3 times, right? And I can beat it down the middle here now, right? Because it hasn't lost that way before, but I couldn't beat it that way again. And after 6 or 8 games, you can't beat it. It knows how to not lose. Again, it still doesn't know how to win. It'll only be luck if it ever does win. But I wanted to introduce the idea of machine learning with that simple example of how a machine learns. The only way that it can learn is through experience. And for a computer, experience is nothing more than data. And so I want to talk briefly about the types of analytics that go into something like this. By far the most popular, the most widely used, one that you all are using every day, is descriptive analytics. If you use Excel, if you have a reporting system, if you look at dashboards, if you, heaven forbid, are looking at how your 401k is doing, you're looking at descriptive analytics that analyze data by doing summarization, averages, and putting that into a form that we can all understand with stock charts or bar charts, pie charts, things like that, that have the descriptive analytics about where we've been and where we are. Then the next step is the predictive analytics, where you take that one step further, and that is all about where I'm going on my current trajectory. So we've seen the projections of, when the COVID-19 might flatten by state, by region, by country, and so on. And so there are predictive analytics that are used to do, you've heard forecasting, right? So it's just forecasting where we're going on our current trajectory using the descriptive analytics to help us see where we are and where we've been. And then the final one, and the one I want to talk about today, is prescriptive analytics. And that's all about being able to say, I see where I've been and I see where I'm going. How can I prescribe? What would I need to change in order to be able to change my future? How can I prescribe the future that I want? How can I, in the area of hourly hiring, how can I choose candidates that are going to be long-term employees? How can I decide the ones that are going to be the right hires based on where I've been and based on the current trajectory? There are things that I can prescribe. There are changes that I can make in terms of my hourly hiring. And that's what we want to talk about today. So before I kind of dive into the data and exactly how we're doing this, I wanted to just talk through the two major types of machine learning. And the one that we just saw is supervised learning. And while that is a fuzzy topic or a fuzzy wording for it, all it means is that we have data from the past that we can quantify, that we know what the outcome was. The reds may be people we did not hire. The blues may be people that we did choose to hire. And so now I can run through all of 2019 data based on all of the hiring patterns from all of the great managers, and also, pulling out the ones that, that we chose not to hire. And I can build a supervised learning system knowing those outcomes. So I know who was hired, I know who was not hired based on my applicant tracking system. And then there's unsupervised learning, where I really don't have, I can't categorize. I don't know what that outcome would be. But what I can do is I can begin to cluster. I don't know if these are the hires and these were not hired. That information is not available to me. But I know that these are all similar based on the data that I have. So I can build clusters that can help inform this supervised learning. So you'll see a lot of clustering, and these could be based on a lot of different variables. But the idea of unsupervised learning is I don't have that past history. All I have is the current state, and I can then cluster groups together based on common attributes. And that feeds into a lot of what we're doing with our supervised learning system. In the case of hourly hiring, it helps us. So what our goal here is with the applicant tracking systems is to always hire like you have. So this is really, instead of artificial intelligence, it's augmented intelligence. Using applicant tracking data and who was hired, we've got the red, we've got the blue, and we can begin to build a system that will hire like you hired. It will bring the same candidates in that you have brought in before. And then if we tie it into a human resources information system that has information about how long they stayed, so this is after they're onboarded, how well they've performed, have they been promoted, have they moved on to other higher responsibilities, are there management assessments that we can feed in there, so that in addition to hiring like you have hired in the past, which is the goal, we really want to hire well like you hired well in the past. And so bringing all of that data together is really powerful in a machine learning system. And it's not terribly complicated. The key is the data and having access to these huge volumes of data to help train. You saw how poor the Tic Tac Toe game is. Imagine if there were not just an X and an O, but 120 or 220 or 1,000 different variables that you had to consider when you're looking at a candidate. Well, that's the reality. That's really where we are. If we look at the data, and this is an eye chart, don't try to focus on it too much. If machine learning is that engine that we're talking about, data is the fuel. The engine is of no use at all if it has a dry fuel tank. It has to have that data in order to be able to learn. And we, the human resources community, have a tremendous amount of data. And at Cadient Talent, we've been collecting this data from over 1 billion applications through time. And we have hiring data on several hundred millions of candidates that have successfully gotten jobs. And then we have the HRIS system about which ones worked out the best. And feeding that into the engine is really the key. We hope to revolutionize some of the analytics that we're doing, but the truth is there are tremendously strong engines, machine learning engines, AI engines that are in the market from Google, from Amazon, from SAS, from SPSS, from R, from Python that I was just showing. Very, very powerful engines. But the data is really the fuel. It's what allows us to pull in individual data about the person and not the job, about the job and not the person, the location, what the job requirements are, and so on. About the person in this job. Have they taken an assessment, either ours or a third-party assessment? What is their availability? Can they work weekends or evenings? So there's all of this data that we have access to that we can feed in to this machine learning engine and be able to augment the hiring decisions. And so many of our clients, and I'm sure so many of your clients, have tremendous number of applications that they have to look through. They just simply can't go through them. And then other jobs go undersourced. We're not getting enough applications in certain areas. So we can use some of the machine learning to help shift the applicants. They may have applied to be a stocker and not a cashier, but their skill set and our need is more for a cashier. You can move them and recommend even if they didn't apply for those jobs. So there's a tremendous amount of value in that data and applying something that is really has been mystical to a lot of people. When you talk about AI and machine learning, it shouldn't be that complicated. It is just using human experience to help a computer make a decision like a human would have done. And it doesn't have to be the final decision. This can augment. We can look through 200 resumes and give the 10 that would have been the ones that you would have hired in 2019. At the end of the day, it really is a human resources problem that we're trying to solve. We're just using the best tools available to help solve it. So with that, again, I apologize for not being able to do this in person. I really look forward to questions, comments, a crackling repartee on the directions we're going, what you're doing, what your companies are doing. I would love to collaborate with any of you. I've included my email address here, and I just really hope we can keep the dialogue going. And until we meet in person, stay safe. I hope your family stay safe and have a wonderful week and enjoy SHRM Talent 2020.